In this video, we're going to take a look at some basic logarithmic equations. And to start that off, we got to understand what this fundamental relationship is between exponentials and logarithms. So here we have an exponential equation, b to the x equals y. And this is the same thing as saying log base b of y is x. All that means is the power of base b that we need to get y is x. Or we can say, what is the power of base b that is needed to get the value of y? A few little examples here is this. We know that b, well, let's pick a number. 2 to the third is 8. Okay, that's something we should be familiar with. Well, if we swing this around, the logarithmic way of saying this is log base 2 of 8 is equal to 3. Log base 2 of 8 is equal to 3, because this asks a question here. The question asked is, what is the power we put on 2 to get 8? Well, the power we put on 2 is 3. So when we're finding a logarithm here, we are finding the exponent that we need, all right? And so let's see, and so we can use this. We can say like 2 to the x, let's say, is 64. Well, this is an exponential equation. We can write this as a logarithmic equation by writing it like this. Log base 2 of 64. Again, this is just asking the same question. Here, we want to know what is the power we put on 2 to get 64. Here, we want to know what is, that's the same question this is asking. What is the power we put on 2 to get 64? Well, right now, we can just go through and we can figure out things that we know about 2. 2 to the third we know is 8. 2 to the fourth is 16. 2 to the fifth is going to be 32. And if you keep going through, 2 to the sixth is 64. So 64 is 2 to the sixth. So we can see that x is 6. So anyways, that's kind of the basic definition. Now let's see how we can use a logarithmic equation or solve a logarithmic equation using these properties. So here we have a log equation. This is log base 6 of 3x minus 5 equals 2. Well, let's rewrite this. Step one is let's rewrite this as an exponential. So take that base, swing it around, and this means 6 to that power of 2 is equal to 3x minus 5, just using that equivalence relationship there. And so we know what 6 squared is. We know that that is 36. So this becomes a pretty simple equation after a couple steps. We can add 5 here, and we have 3x equal to 41 divided by 3, and x is 41 thirds. Okay. Now we do need to check this because a logarithm cannot be negative. We can't put a negative number inside of a logarithm. And so we do have to check this out. We've got to plug this in to see if it makes this 0 or negative. All right. And so log base 6 of 3 times 41 thirds minus 5. Well, the inside becomes 41 minus 5, log base 6 of 36. And we ask ourselves, what is the power we put on 6 to get 36? Well, that power is 2. So this is equal to 2. And that's what we wanted. So it checks out. All right? Here's another one. This just says the log of x squared plus 1 equals 1. Well, this is called a common log. When there's no number written down on the bottom, when there's no base, when it's invisible, it's really log base 10. So I'll squeeze that in there right now. So when there's nothing written, it's log base 10. We're going to do the same thing. Rewrite this as an exponential. X squared plus 1 equals 10 to the first, which is just 10. So x squared plus 1 equals 10. Subtract 1 from both sides. And then let's square root that thing. And when we square root, we're going to get two answers. we're going to get x equals 3 or negative 3. And we've got to test those out here. When we plug these in, we're going to get log of 3 squared plus 1. That's log of 9 plus 1, which is the log of 10. And this is the question, what is the power we put on 10, the invisible 10 here, to get 10? Well, the power is 1. Okay, so I should copy the right side of the equation down. This is 1 equals 1. That checks. Okay, and the other one we really don't need to check too carefully because we plug negative 3 in there. Log of negative 3 in parentheses squared. Is that equal to 1? Yeah, because this is going to be log of 10. And log of 10 is 1. And you can go to your calculator to check this out, okay? Your calculator has a log key, and the key that just says log is going to be a base 10 log. Okay, there you don't have a key that does base 6 like the last problem, but you do have one that does base 10. So anytime you want a base 10 logarithm, go to your calculator. Last one, here we have ln. ln is a natural log. This is a natural log. And the natural log, a rhythm, I should say. The natural log, okay, has a base e. This is the natural number e. It's about 2.718. It's kind of like pi. But there's this base. So this is like saying log base e. We don't usually write it this way. Not a big deal if you do when you're getting used to things. So it's going to act just the same, but we've got this number e. And this number e, it's about 2.718. So it's going to act like the 6 or the 10 did it in the last couple of problems. And let's rewrite this as an exponential equation. E to the third. E to the third is just some number, so let's leave it as e to the third for the moment. We can subtract 4 to both sides, and we're going to write e to the third minus 4. And if you go to your calculator, you have an e key, but let's not go decimal with it yet. Let's divide by 3, divide by 3. So the exact answer is e to the third minus 4 divided by 3. Now if you go to your calculator, type this into your calculator, you have an e key that will give you e to the third. If you type in, hit the e key and the exponent of 3. Minus 4, you got to put that in parentheses. Watch out. Put that in parentheses, divide by 3, and see what you get. And this gives us a decimal number of about 5.36. Okay? There's the approximate answer. There's the exact answer. And we can test that out. This one we can test out on our calculator by just going to our calculator and typing natural log of 3 times. Now there's going to be some rounding error here, but it should give us something close to 3. So if you type that into your calculator, see what you get. And you got to make sure that's all in the parentheses here, ln with all of that. And we should get about 2.9997, which is approximately 3, because we rounded off to 2 decimal places. So anyways, there's our answer. That's how we solve a logarithmic equation. Change it to an exponential by swinging this base around, and then just compute that exponent there and solve it like a regular equation, a linear or quadratic equation, whatever it is.